of course, that the exploration of the brain helps to, well, develop certain hypotheses and to test certain hypotheses in certain cases relevant for the development of psychology, at least as indicators or markers that can be associated to mental processes. But at the same time, neuroscience had to be open with respect to the influences coming from the more abstract science like psychology. And in fact, during the last century, the distinctions that have been made in psychology, on psycholinguistics, in psychology of perception, have been very useful for the exploration of the brain. So the interaction is in both ways. And I suppose, that we cannot be afraid of the dangers of being abused by the cognitive neuroscience. Stop. Thank you.
Okay. Thank you very much for your thoughtful and thorough
I'm sorry for
discussion.
being late.
No problem. So we have time for a couple of questions. So, anyone? No? Okay.
Yes, please. Okay. That's good.
It seems to me that this critical view, cognitive neuroscience, is based on the assumption that the stance of psychology,
That day?
the stance of psychology, the object and the methodology, was defined once and forever sometime in the past, probably in the middle of the 20th century. And I would like to know what this object and methodology should be from a proper psychology according to him.
Well, the delimitation of the field of study is an important enterprise that any discipline has to face from the beginning. But I don't agree that it has been forever delimited without any change or modification. I think it's a kind of feedback or interaction between the consideration of the field, the limits that you need to define in a previous way, sometimes even pre-theoretically, based on intuition or in former data and in the achievements of other disciplines. You had to define the domain of phenomena that you want to. But that kind of definition is not rigid, has not to be rigid, because it changes, it's very dynamic, and the development of the discipline through the history of the discipline can modify. For example, mental life. When we say mental life, the way in which the first scientific psychologists understood mental was very much different from the way in which cognitive psychologists understand mental. First of all, because the characteristic or the property of consciousness was very central in the consideration of even the first experimental psychologists, the conscious experience. And there is a big period of, at least 40 years or so, a big process in the history of psychology by which we finally had to overcome what I have called in certain publications in Mente Conducta, for example, the prejudice of the first mentalism, the primitive mentalism, that was the mental equals conscious. Most of it was the central property. You analyze the contribution of Freudian psychology. I don't want to enter into the details of psychoanalysis, but the important role of Freud in the in the way in which, but not only Freud, William James, that consider that even if he spoke about the flow of consciousness, but consider it make a break in that dichotomy between conscious and unconscious, saying that conscious can vary, in a continuum, by which there are equally important for the understanding of the mental life, the automatic or very well learned processes, instincts, etc., can be considered also mental, that the very conscious, effortful, and attentive processes. And finally, in the cognitive paradigm, under the cognitive paradigm, mental have been avoided any mixture with consciousness. Consciousness could be a characteristic of some mental processes, but probably not the more relevant for the modeling of mental activities and processes. So it's just an example of how the definitions of the limits that you pose at the beginning of the enterprise had to coincide with the things that, so it's dynamic, I think. I don't know.
Science is dynamic in itself.
Yeah, that's why.
Every science.
That's why it's not rigid, the limitation that you...
But sometimes feel that these critical views towards cognitive neuroscience are too rigid.
Yeah? You think so?
Well, I don't agree that psychology and neuroscience are different things. I only think that if you try to understand how the mind works, you need different resources, you need different techniques, you need to refer to different levels of
Yeah.
explanation.
Yeah.
Do you want to stick only to one level of explanation, which is the
No.
computational one? That's my impression.
Yeah, but no, I suppose that finally it has to be what Wilson calls consilience, in the harmony of all the levels and all the sciences. We hope someday we arrive to that consilience. But I think that, and it's important to try to relate levels. But in psychology, we know a lot about that with the neuropsychological tradition, without waiting until the advancement of the neuroscience, the cognitive neuroscience. We know a lot about that kind of interaction and that kind of mutual profit that we can have from one to the other. David Marr itself recognizes that a complete explanation requires the integration of the research and the advancements that we can make in all these levels, that he distinguishes: the computational level, the algorithmic level, the implementational level. Of course, we, with our curiosity and we need of knowledge, want to, and that's why I had tried to review the history of psychology in a very schematic way, saying that this problem about this is the mind-body problem, finally. The thing is that cognitive neurosciences, I think, with the spectacular achievements that he has, and so visible, I doubt that has made a step of progress in that direction. But even if we as psychologists can take advantage of these techniques, but not to solve the problem of how the brain makes the mind, but to improve our knowledge of the mind, like we use reaction times, like we use EERs in even related potentials, we can use, of course. I am not prescribing to use fMRI or to use PET or other technologies, magnetoencephalography or whatever. It's just that probably the expectations that we have with those techniques, at least until now, have not been accomplished in that sense. But even if they can be very useful as indicators of mental processes. So a technology that is subsidiary of the the ends and the goals of the psychological research, in psycholinguistics, in perception, etc. I think they are useful. I don't deny that. I don't know.
But let me say something, if I can, concerning these questions. And I will ask to you, and maybe to be more provocative and more drastic in the answer, because you've been trying to get to an agreement, but I don't like that. I mean, what I would ask you, if something can be explained neurologically, what room do we have for psychology? It's not psychological, period, full stop, out. I mean, if it can be explained neurologically, that's it. I mean...
By something you mean...
Yeah, for instance, you have whatever process. I want to explain edge detection in vision. Okay, edge detection. If I can find cells that explain the whole thing, what do I have to do as psychologists? And that's welcome. We are glad that that's explained physiologically. There's no problem with that. But why do you say that that's psychology? So the question for you, not for you, the question for you is, if something can be explained physiologically, do psychologists have to say something about that process or not? I don't think so.
Well, it depends. Let's see. If the neurophysiological or neurobiological explanation explains, as you say, explains,
yeah,
in the sense that you dissolve the psychological phenomena to dilute it, and you don't need any appeal to, I don't know, intentional, computational, or cognitive or factors, then probably you are dealing with some systems that provide something to the mental architecture or to the cognitive architecture, but are like in the interfaces with the physical system. Is the argument, for example, to identify transducers in perception. Transducer, and that's a view very well adopted by very cognitive psychologists like Zenon Pilichin or even Jerry Fodor, transducers operate physically. We don't need to attribute them any computational operation to do what transducers are supposed to do. That is, transform a kind of energy, the stimulus energy, the proximal stimulus energy, into the stimulus with which the nervous system works. It is electrical impulses and signals, and etc. Then you can consider that result or output of a physical process has to have some kind of computational relevance as the first signals from which the computational system works. But you don't need, of course, you don't need a computational theory or a cognitive theory or a psychological theory to explain the transducers.
That's neuroscience.
But probably in that kind of integration that we were speaking about, it's interesting to know, at least to discover, that these physical systems connect with the mind. Pilichin himself says that transducers are the bridge, or can be the bridge, in general, also perceptual activity in the very low levels between the physical and the mental world. And that would be interesting to have these connections, these bridges between the physical and the mental. If not, we are very lost about the consilience question.
Okay, I agree.
But anyway, I think that we can make progress, of course.
We have another question over there, Susana.
Oh, Susana. Wow. How long?
And how far? Even with yourself?